Hello friends, welcome to lecture series on essential mathematics for machine learning. Now we will see how we can find out expectation and variance of a distribution function of a random variable, sorry. Okay. We want to find out expectation and variance of a random variable, how we can find. So, what do you mean by expectation first? So, expectation of a random variable x denoted by E of x is the probability weighted average of all its possible values. So, basically sometimes we also call expectation of x as a mean of a random variable x. So, formally expectation of x is defined as, we denote it by mu also, which is expectation of x, and for discrete case it is simply summation of x f x, where f x is the PMF of x, and if it is continuous then it is integral from minus infinity to plus infinity x f x, where f x is in this case when x is continuous, in this case f is simply PDF, okay, probability density function. Now we have an important property of expectation, that is for a random variable x and a constants a and b, expectation of a x plus b is nothing but a times expectation of x plus b. So, let us discuss this thing now. So, we have seen that if we have a random variable x, then expectation of x is given by summation over x f x, if x is discrete as we discussed, and it is integral from minus to plus infinity x f x dx if x is continuous. Now, suppose you want to find out expectation of a x plus b. If x is discrete, then how we can define expectation of x? Simply given by summation x f x. So, it will be simply summation of a x plus b into f x, summation over x if x is discrete. Okay. So, this is given by summation a x f x plus b times f x, summation over x, and this is further can be written as a times summation over x x f x plus b times summation over x f x, and this can be further written as a times. Now, this is what? This is nothing but expectation of x as per the definition of expectation of x when x is discrete. So, this is nothing but expectation of x plus b times. Now, summation of f, because f here is PMF. So, this is nothing but 1, summation of f x is 1. So, this is into 1. So, we can say that it is a times expectation of x plus b. So, basically we can say that expectation follows linearity, that is a x plus b is same as a times expectation of x plus b. This is for the discrete case. Now, similarly, if x is continuous, in that case expectation of a x plus b will be given by integral minus infinity plus infinity a x plus b into f x dx. So, which is nothing but a times integral minus into plus infinity x f x dx plus b times integral minus plus infinity f x dx. And as per definition of expectation of x, this term is nothing but expectation of x. So, it is a times expectation of x plus b, and again this is 1, because here f is nothing but PDF of x. So, this is into 1 again. So, this is equal to a times expectation of x plus b. So, we can say that expectation of a x plus b is always a times expectation of x plus b. So, this is an important property of expectation of x. Now, let us discuss few problems based on expectation. suppose you have a discrete distribution, here you have a discrete distribution given by y plus 2 upon 25, this is basically PMF. Okay. This is probability mass function of this random variable y, which is given by y plus 2 upon 25, y is varying from 1 to 5, and you want to calculate, you want to find out the expectation of this variable, this random variable y. So, how can you find? So, here what is PMF? PMF of y is, it is Fy, which is given by y plus, this is y plus 2 upon 25, where y may be 1, 2, 3, 4, 5. Now, you want to calculate expectation of y, random variable y. So, this is as per definition, this is nothing but y into Fy, okay, as per the definition of expectation of y, and here y is varying from 1 to 5, because the values of y may be 1, 2, 3, 4 or 5. So, this is further equal to y varying from 1 to 5, y times y plus 2 upon 25. So, this is 1 by 25 times summation y varying from 1 to 5, this is y square plus 1 by 25 times, in fact 2 upon 25 times summation y from 1 to 5, it is y. Now, this is nothing but, this is further equal to 1 by 25 times. So, this is 1 square plus 2 square plus 3 square up to 5 square. So, we know that either we can find out directly the sum of squares up to 5, or we can use the formula. We know that sum of n square is nothing but n plus 1, 2n plus 1 by 6, sum of squares of natural numbers. So, we can use this expression here. So, it is basically n is 5 here. So, it is 5 into 6 into, when you substitute 5 here, it is 11 by 6, and plus 2 upon 25 times, it is sum of natural numbers up to 5. By the formula we know that it is nothing but n plus 1 by 2. So, it is 5 into 5 plus 1 is 6 upon 2. So, now when you simplify this, so 6 is cancels out and it is 5 times cancel out. So, it is 11 by 5 plus, it is 5 times cancels out and it is 2 cancels out. So, it is 6 upon 5. So, this comes out to be 17 upon 5. So, this is how we can compute expectation of this random variable y for this problem. Okay. Now, if you have a PDF for a continuous random variable given by this expression, so in this case how you can find expectation? So, expectation can be found in this way for this example. Now, what is PDF here? PDF is given by Gx, which is x when x is between 0 and 1, and it is 2 minus x when x is between 1 and 2 and 0 elsewhere. Okay. Now, you want to find out expectation of x. So, this is as per definition, it is integral minus infinity to plus infinity x gx dx. Okay. Here PDF is given by gx. So, gx will come here. It is further written as, now this integral is 0, otherwise only except 0 to 2. 0 to 1 is defined like x, and 1 to 2 it is 2 minus x. So, we can say it is 0 to 1 given by x. So, it is x square dx plus, and 1 to 2 it is x into 2 minus x dx. So, this will be x cube by 3, which is 1 by 3 plus, this is 2 into x square upon 2 from 1 to 2 minus, it is x square, that is x cube upon 3 from 1 to 2. So, this is 1 by 3 plus 2 cancels out. So, it is 4 minus 1 is 3 minus, it is 1 by 3 times, it is 8 minus 1. So, the final answer will be, it is 9 plus 1 10, this is 10 by 3 minus it is 7 by 3. So, that will be nothing but 1. So, in this way we can find out expectation of random variable x for this PDF. Okay. Now, this is a property based problem, a simple problem. It is known to us that expectation of 2x is 10, expectation of y plus 3x is 25, then how can you find out expectation of 4x minus y? So, now in this problem expectation of 2x is known to you, expectation of 2x is what? Is 10. So, this implies 2 times expectation of x is 10, as by the property of expectation of x. We know that expectation of ax plus b is nothing but a times expectation of x plus b. So, this is further written as expectation of x is 5. So, this is expectation of x. Now, expectation of y plus 3x is 25. So, expectation of y plus 3x is 25. So, this implies expectation of y plus 3 times expectation of x is 25. So, you can substitute expectation of x as 5 here. So, this implies expectation of y plus 15 equal to 25. So, this implies expectation of y equal to 10. Now, what you want to find? We want to find out expectation of 4x minus y. So, expectation of 4x minus y will be 4 times expectation of x minus expectation of y. So, this will be 4 times expectation of x is what? Is 5, we have calculated here, minus expectation of y is what? 10. So, it is 20 minus 10, that is 10. So, 10 is the final answer. Now, let us come to variance. How can you find out variance of a random variable x? So, variance of a random variable x is a measure of a spread or dispersion of x about the mean. Mean is nothing but expectation of x. So, if you want to find out the how much random variable it disperse, this is spread about the mean, that measures by variance of x, and mathematically it is given by expectation of x minus mean whole square. That means, it is simply average square deviation of the values of x from the mean of x. So, how can we define variance? Now, you can see here variance of x is nothing but expectation of x minus expectation of x whole square. Okay. So, that means simply expectation of x minus mu whole square, if we denote mu by expectation of x. So, let us simplify this. So, it is a minus b whole square. So, it is a square plus b square minus 2ab. Okay. Now, you can further simplify it. It is expectation by the linearity property, it will be expectation of x square plus expectation of mu square plus expectation of minus 2x mu. So, it is expectation of x square plus, now mu square is a fixed value, mean of a random variable is a fixed expression, fixed quantity. So, this will come out. So, this is simply mu square times expectation of 1. Okay. And here minus 2 mu will come out, and it will be nothing but expectation of x, because here also minus 2 times mu is also a fixed quantity. Now, what is expectation of 1? Expectation of 1 is nothing but 1, because if you find expectation of 1, because you see expectation of ax plus b as we already derived, it is a times expectation of x plus b. If you take a as 0 and b as 1, so we get expectation of 1 equal to 1. Okay. So, in this way it is expectation of x square plus mu square minus 2 mu, and what is expectation of x here? It is mu. So, it is into mu, that is mu square. So, this will be expectation of x square minus mu square, and that will be expectation of x square minus expectation of x whole square. So, in this way we can get, if you want to find out variance of Ix, that how much it is dispersed about mean, then that can be measured by this expression or by this expression, the simplified one, that is variance of x is expectation of x square minus expectation of x whole square. So, we can say that since variance of x is always greater than or equal to 0. So, that implies expectation of x square minus expectation of x whole square is always greater than or equal to 0. So, from this we can conclude that expectation of x square is always greater than or equal to expectation of x whole square. Okay. So, this is one result, that expectation of x square is always greater than or equal to expectation of x whole square. Okay. Now, if you want to calculate variance of Ax plus b, so how for constants a and b, so how we can find out variance of Ax plus b? So, variance of Ax plus b, as if we apply the basic definition, so that is nothing but expectation of Ax plus b minus expectation of Ax plus b whole square. This is as per definition of variance of x. Instead of x, now we are having Ax plus b. So, you simply replace x by Ax plus b. Now, this is further equal to expectation of Ax plus b. Now, here you apply the linearity property of expectation of x. So, that is a times expectation of x minus b. So, this b will cancel with this b, that is so that means that further implies it is expectation of Ax minus a times expectation of x whole square, and that is further equal to expectation of a square into x minus expectation of x whole square. Now, again this is a constant quantity, so it can taken out by the linearity property of E, I mean expectation. So, that is a square times expectation of x minus expectation of x whole square. So, and this is nothing but variance of x. So, we can say that a square times variance of x. So, we can say that if we add or subtract a fixed number from each random variable x, then variance is unaffected. However, if you multiply x by a certain number, say certain constant, say a, then it will be nothing but a square times variance of x. I want to say that if you want to find out variance of alpha x, so that simply variance is alpha square times variance of x. If you want to compute variance of x minus a, so that nothing but variance of x itself. So, that will not I mean the if you add or subtract something with a random variable, that will not affect the result on variance of x. Okay. Now, let us discuss few problems based on variance of x. Okay. Now, suppose you want to find out variance of random variable x whose PMF is given by x by 15 when x is from 1 to 5. This is a discrete case. Okay. So, how we can find variance of this? So, here what is the PMF of x? That is simply given by x upon 15, where x is between 1, 2, 3, 4, 5. Okay. Now, you want to compute variance of x. So, variance of x as per the formula, it is as per the expression, it is expectation of x square minus expectation of x whole square. So, you want to compute two things, first expectation of x square and then expectation of x. So, let us compute expectation of x first. So, it is a discrete case, so summation will come and x f x, and x is varying from again 1 to 5. So, this is summation. Now, this is x square upon 15, you can substitute x as x upon 15, x is varying from 1 to 5. So, 1 upon 15 will come here and it is summation x varying from 1 to 5 x square Now again it is what? It is nothing but sum squares of natural numbers up to 5. So, as by the formula of sum of squares, it is 5 into 5 plus 1, that is 6, into 2n plus 1, that is 11 upon 6, and n plus 1, 2n plus 1 by 6. So, this cancels out, 5 into 3 times cancels out. So, it is 11 upon 3. Now, let us compute expectation of x square. So, it is summation x square f x. X is varying from 1 to 5. Okay. So, it is nothing but summation x is varying from 1 to 5, it is x cube upon 15. So, how can we compute x cube upon 15? So, it is 1 upon 15 times sum of cubes of natural number up to 5. So, that is n plus 1 upon 2 whole square. Okay. You can find directly also. So, that is nothing but it is 1 upon 15 into 5 into 5 into 3 into 3. Okay. So, that is this cancels out. So, it is 15. Okay. So, what is the final answer now? So, we want to compute variance of x. So, variance of x is now given by first is expectation of x square, from here is 15. So, it is 15 minus 11 upon 3 whole square. So, it is 15 minus 11 upon 3 whole square. Okay. So, you can simplify this, and that will be the variance of this random variable x. Okay. Now, what is the variance of random variable z, whose PDF is given by this expression. So, now let us compute for this continuous case, this is a continuous case. So, now PDF is given by 2 e raised to power minus 2 z, and z is greater than 0. Now, for this you want to compute variance of x. So, again for variance of x, we have a simple expression, that is expectation of x square minus expectation of x whole square. Now, first expectation of x is now it is a continuous case. So, it will be integral minus 1 plus infinity. So, it will be z into f z or h z dz. So, basically here instead of x we are having z, anyway that is not a problem. So, it is given by, now it is 0 to infinity, it is z 2 into z e raised to power minus 2 z dz, because we assume that otherwise it is 0. Okay. I mean only for z equal greater than 0 it is defined like this, otherwise it is 0. So, now it is 2 times, now we have to integrate this. So, we have to apply by parts, integral by parts. So, when you integrate by part directly, so it is minus 2 z upon minus 2 and minus derivative of first and integral of second, that means e raised to minus 2 z upon 4, and that is from 0 to infinity. Okay. So, now it is further equal to, now first what will happen if z tending to infinity here. So, let us try to compute limit z tending to infinity z into e raised to power minus 2 z upon minus 2, it is equal to limit z tending to infinity z upon minus 2 e raised to power 2 z. Okay. As z tend to infinity, it will tends to infinity upon infinity, you can take minus outside. Okay. So, this will be nothing but, so when it is infinity upon infinity, you can apply L'Hospital rule. So, it is limit z tending to infinity minus the derivative of numerator, and derivative of denominator will come in the denominator. So, it is 4 times e raised to power 2 z, and as z tend to infinity, this will tend to infinity and this will tends to 0. Okay. Here also when z is tending to infinity, this will tends to 0. So, what is the final value of this? So, So, hence expectation of z will come out to be. So, when z is tend to infinity, both terms are tending to 0. So, from the upper limit it is 0, from the lower limit when z is tending to 0, it is 0 because z is here, and it will be 1 upon 4, negative negative will be positive. So, it is 1 upon 4 into 2, that is half. Okay. Now, let us compute expectation of z square, then only we can compute variance of z. So, what will be expectation of z square? Expectation of z square will be, now it is integral 0 to infinity, it is 2 z square, I mean here it is what? It is 2 e raised to power minus 2 z. So, it is z square e raised to power minus 2 z dz. So, it is 2. Now, again you can integrate, it is z square e raised to power minus 2 z upon minus 2 minus derivative of first integral of second plus derivative of first next integral of second. So, basically you have to apply by parts 2 times, you will get the same answer. Now, again when z is tending to infinity, by the same procedure as we did here, in this by the same procedure this will also tends to 0, this will tends to 0 and this will also tends to 0. So, as z tend to infinity, all the 3 terms are tending to 0. Now, when z is tending to 0, it is 0, it is 0 and this will be 1 by 8, I mean minus 1 by 8. So, when you are taking 4 times, so it is nothing but 1 by 2 again. Okay. So, what will be variance of z finally? So, variance of z, which is this expression, so this will be 1 by 2 minus 1 by 4 and that will be nothing but 1 by 4. So, in this way we can find out variance of this PDF, variance of random variable z for this PDF. Now, the another problem is basically based on the property of variance of x. So, if variance of x is 4 and variance of 4y is 32, how can you find out variance of 2x minus 8 or variance of y plus 2? So, for here variance of y plus 2 will be same as variance of y. We know that because addition or subtraction will not affect the value of the variance. So, and what is variance of y from here? See, if variance of 4y is 32, if variance of 4y is 32, so this implies 4 square times variance of y is 32. So, this implies variance of y is, it is 2, okay, which is same as variance of y plus 2, that is variance of u or v, variance of u, yes. Okay. Now, from the first one, variance of x is 4, now you want to compute variance of z. So, if variance of x is 4 and till variance of z, which is variance of 2x minus 8, will be nothing but 4 times variance of x, which is 16. So, using the property of simple property of variance, we can find out these two values. Let us solve one more problem based on this. Consider random experiment of rolling 2 dice simultaneously. So, you are rolling 2 dice simultaneously and you want to find out expectation and variance of modulus of difference of 2 numbers that come up. So, here random variable is basically, here the random variable is basically the modulus of difference of 2 numbers. So, what will be x? So, here x denotes the modulus of difference of 2 numbers. Now, the difference of when 2 dice are thrown, the difference, the minimum difference between the 2 dice will be 0, modulus, because if both numbers are same on the dice, then 1 minus 1 will be 0, 2 minus 2 will be 0. So, the minimum difference is 0. It may be 1 also, suppose you are having 1 or 2 or 1, modulus is 1. It may be 2 also, 3, 4. What will be the maximum difference? So, maximum difference will be when one die has a minimum value and the other die has a maximum value. So, one die has a minimum number, that is 1, and the other die has a maximum number, that is 6. So, difference will be 5. So, the maximum difference will be 5 only. So, this will be the different values which this random variable can take. Now, what is the probability of this? Now, when it is 0, where 0 it will be when it is 1 1, 2 2, 3 3, 4 4, 5 5, 6 6, that means 6 cases, 6 cases out of 36. Okay. Now, when it will be 1? It will be 1 when you are having 1 2 or 2 1, it will be having say 2 3, 3 2, it will be having 3 4 or 4 3, it will be 4 5 or 5 4, 1 2 3 4 5 6 7 8. So, it will be having 5 6 or 6 5. So, these are the 6 cases, these are the 10 cases, sorry, these are 10 cases when a difference is 1. You can see modulus of difference is 1. So, these are 10 cases. Similarly, when difference is 2, so there will be 8 cases, you can check. Now, it is 6 cases, it is 4 cases, these are 4 cases, and for 5 these are the 2 cases only, 1 6 or 6 5. Now, if you want to compute variance or expectation of action, mean of this random variable. So, mean will be given by summation x p x. So, this will be 0 into this is 0 plus 10 by 36 plus 16 by 36 plus 18 by 36 plus 16 by 36 plus 10 by 36, and that will be nothing but 35 by 18. If you simplify, so that will be nothing but 35 by 18. You can simplify and you can find out. Okay. Now, what is expectation of x square? Expectation of x square is summation x square p x. So, that will be this into this is 0 plus 10 by 36 plus 4 into, you have to make a square of this and then multiply with the respective probability. So, that will be 8 by 36, similarly 9 into 6 by upon 36 plus 16 into 4 upon 36 plus 25 into 2 upon 36, and that simply will be given by 35 upon 6, that you can verify. Now, what will be variance of x now? So, variance of x will be, so this is expectation and variance of x will be as per the formula, it is expectation of x square minus expectation of x whole square. Expectation of x square is what? It is 35 by 6 minus expectation of x is what? 35 by 18. So, this value will come out to be nearly, it is 2.0524. So, you can simplify and see. So, in this way, if you are having these type of problems where you have to, where some random variable is given to you and you have to find out expectation and variance, that also you can find. So, basically in this lecture we have seen that if a random variable is given to you, maybe discrete or random, then how can we find out expectation, that is mean, or variance of that random variable. In the next lecture we will see that what are the various distribution functions and how we can find out their mean or variance. Thank you.